So we've got some engine assembly lube. We've got a rocker cover gasket. We've got a duplex valve spring kit, so that just seems to be the big and small valve springs in that bag. Then we have some retainers or valve caps, they look more like. No, they were the... yeah, these are the seats. It's interesting that there's a little bit of, looks like surface rust on them. I need to double check on the website, but I'm sure they were advertised as being stainless steel. Interesting. And here we've got some valve hushers. Should be 8 of those for an 8 valve engine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Valve stem seals. 1, 2, 3, 4, 5, 6, 7, 8. A camshaft front seal. A large seal for the distributor on the back of the cam. Small seal for the distributor on the back of the cam. And here adjustable camshaft sprocket, so you can get the most out of the cam timing. Did order the one with the round tooth pitch. That looks a bit square to me, but yeah, it is square, so I might have to just double check that, but that's possibly not the correct one. All engines after a certain year, I think it was 93 onwards, might be wrong on that, were a round tooth design. Okay, so I have given the company a call, spoken to somebody, and yeah, this is the square tooth one. I thought it looked a bit square, so that is going to be sent back. The correct one's going to be sent to me first thing tomorrow morning, I've been told, and yeah, they're going to supply me with credit for whatever it costs to send this, and I should have all the right parts then. So I have also found out that the valve stem seals only they're only needed on the intake side, so I only need 4 of those. And these retainers and seats for the valve spring kit, they do just get slight oxidation on them in storage, and I was advised to give them a light abrasion, a light cleaning with an abrasive, you know, mild wet and dry or wire wool, which is, you know, it's not ideal when you're spending extra money on a special kit. You kind of want it to come all all ready to go. Just a little bit of extra work, it's just a bit of inconvenience really. You join me on this lovely winter's day, and we're about to get cammy. Very cammy. Cam upgrade. Let's release the bonnet. Car needs a wash. Removing the HT leads and the dizzy cap, along with the spark plugs and the rocker cover or valve cover, however you like to say it, and the upper timing cover, and we can go from there. So let's start with a really fiddly bit. You're going to need an 8mm. I'm using a ratchet spanner, and with this, providing you've got enough teeth on your ratchet spanner, you can, better if I had it in short, you can just get onto the nut there, to the bolt even, and ease that out, and that's the top one on this. There are 3, so you've got one there. Just get some light on the situation. You can just see the other one there on that side, and down here there is one. Where is it? There. So yeah, just undo those 3. You should be able to ease the distributor cap out of position. Obviously if you're having trouble getting to the middle one, you can pop the HT leads off. It's providing you've not got some aftermarket universal HT leads and they're a proper set, they're all varying lengths, then it's pretty obvious which lead goes to which spark plug. What's not obvious is which lead goes to which output on the distributor. So if you've not marked them or took a picture of them or got a manual and you do take them off, you might put them on the wrong way around. So I'm going to keep them on because I can, and if I do want to take them off, I'll just mark them or take a picture. So let's get this off. So if you're doing this yourself and you're trying to get to this one, it's a little bit tighter, and you might end up doing the same as me and knocking this vac line off there, which is the feed for the heater valve. So if you knock that off and you don't know about it, you might realise when you've got no heater working, and you might realise when your idle's not the same because it's idling a bit higher than usual because there's a vac leak. So yeah, just be careful of that. Also, these lines can be very brittle, so you might want to check to make sure it's not got a crack in it. They can easily snap, and you can obviously just replace them pretty easily with a piece of vac line, or you can do repair sections with a small piece of vac pipe. Okay, that's my dizzy cap off. Just going to get the rotor arm now and slide that off. So these were recently replaced, so they're in good condition. Just going to pop those to one side. If you do have the proper tool for depressing the proper on head valve compressor tools, I don't know if there's any that you can buy actually that hold the valve up whilst they're doing their job. I'm going to go for the rope in a combustion chamber method, which requires me to put some rope into the combustion chamber via the spark plug hole. Therefore, spark plugs need to be coming out, and if that's the case, then the HT leads need to be off. So that's why I'm pulling the whole assembly off here. And if that doesn't make any sense to you now, hopefully it will when I get to that stage. So that's the HT leads out the way. I'm just going to get a spark plug socket on these now with an extension and remove the spark plugs, which were also recently replaced. So that's the first spark plug out there, and as you can see there's like a browny beige colour on the tip. It tells us that we're running a good mixture, which so it should be. Everything's standard except the boost, but the boost is running at a level that the ECU can meter the fuel and air for. So let's get the other three out, and this is using a 16mm spark plug socket, by the way. 4 happy plugs out. So next thing is top timing cover. So we're going to need 10mm socket there, 10mm socket there, 12mm socket on that one, and on that one T27 Torx bit, and that should bring the top timing cover off. So once the bolts are out of here, there is a little bit of wiggling involved and a bit of negotiating to get this out, because there is this will get caught on the belt, and that part down there is wrapped around the top of the water pump. So you can give it, I don't know what the correct procedure is, but you can give it a bit of a wiggle and it'll come up and off like that. So that is this piece off. Now I'll go ahead and take the rocker cover off with some 10mm, get the 10mm bolts off there, or nuts, can't remember which way around it is. Yeah, so it was nuts, and obviously on the back, on the distributor end, you have 2 earth cables that are secured on by those nuts. I don't know who it was. On one of the previous videos someone said this didn't have the 2 earth cables that it should have had, but there's one and there's the other. So that was on there a second ago, I've just loosened it now, and that's the other one attached. They're both going up to a common earth on the bulkhead, so it does have its earths, and obviously you should make sure they go back, make sure they're nice and clean as well, make sure you're not getting any build up of resistance which will cause bad earthing and weak spark or sensors to not read properly, that kind of thing. Okay, so all the nuts are off the rocker cover there. So you can lift that up now. It may be a little bit stuck, but there we go. You can just release the whatever kind of hold the gasket had on that. Now we've got this ventilation pipe which may be in the way. You can sneak the rocker cover out without it, but it might be easier to remove it, so I'm just going to remove that. It very easily slides off. And then again you've got this vac slash boost pipe here that goes to the research valve. Comes with this tag, or it should do. That was held down by one of the nuts, so that needs to go back there. And again, it'd be easier to disconnect this pipe to get the rocker cover off. So I'm going to do that now. Okay, so now that that is off, we've exposed the cam and half the gaskets sat there and the other half will be on the cover. What we want to do next is just get ourselves to top dead centre so we know where we're at. So as you can see there, there's a dimple on the cam pulley. Someone's kindly coloured it in. with what looks like pink nail varnish or nail polish, whatever you want to call it. Then there is a dimple in the back plate behind the cam gear, you can just see there, and someone's kindly put a little mark there for us as well. So we're actually not too far off top dead centre. Now, as you probably well know, the cam will turn half the speed of the crank, so it's possible that you could get the crank to top dead centre and the cam would be 180 degrees out. You would be at top dead centre there, but not for the cylinder number 1. So we want it for cylinder number 1, top dead centre. So we need to make sure that both the crank and the cam timing marks are lined up. For the crank, we have these timing marks here, which need to coincide with a notch on the crank pulley, and I have a 24mm socket on the crank pulley, which goes onto the nut, the retaining bolt for the crank. And as you can see there, someone has very kindly made a mark where there may be a very slight indent that we can't see because of the mark, but that is what needs to line up with the 0 on there. So if I turn the engine over in the clockwise direction, don't want to do it, you don't want to turn it back because engines just don't like that. It can cause scoring and stuff, things to rub up against other things that don't usually rub up against them that way. As you can see, getting pretty close on the cam, and as I ease that in, we're almost dead on there. Don't need to be dead on, it's not an interference engine, and we're going to be rocking it out of top dead centre anyway at some point. We just need to know that we're on the right stroke. Well, I can't see a notch, but I can see the mark that someone's left us, so I'm going to have to tell myself that there's a notch there. Everything else lines up though, and I can't see a notch anywhere else on the pulley. So I'm guessing there's a very light notch, and that is actually preventing me from seeing it. Clamp the belt to the pulley and apply some tension to the pulley upwards so that it can be suspended once I release the belt tension and remove the pulley. So what I've done is I've put my own little mark on there between the cam pulley and the belt, so I know where the belt is in relationship to the cam pulley. Then I've just clamped the belt to the cam pulley using a bit of cardboard to act as a cushion so that I don't damage the belt, and I've put some chalk pen marking down there where the sprocket meets the belt. Now what you could do obviously is take off the harmonic balancer and the bottom timing cover and make sure that the bottom pulley, the crank sprocket, is marked to the belt as well. As long as we know that the belt hasn't moved off the two lower pulleys, we know how to put it back onto the top pulley. Then I've got this bungee cord just linked to the inside of the bonnet, and just propping it up with an umbrella, why not? So yeah, it's a little bit haphazard, but it'll do the job, and it's just for peace of mind really. So I can now hold that the cam pulley still using a tool which I'm guessing you can buy them, but I have made one, just something that sits inside the gaps and allows you to lever against the bolt to undo it, and then I'm going to undo that bolt. For now though, the next thing to do is to release the tension from the timing belt, so I'm going to use a 15mm socket and just undo the nut on the tensioner. If I can get the socket on the ratchet with the one hand. There she is. So undo the tensioner. These are spring loaded, so nothing's going to go twang. And now I can use a blunt object to push this way to release tension. And what you can then do, I can't quite see where it is at the moment, but I'm assuming that as you push and release the tension, you're going to compress this spring and you're going to reveal an orifice in which you can place a 3mm key or tool. I'm going to use a drill bit that will keep the tension on. That will keep the tension on the spring, therefore keep the tension off the belt. And then we can undo the cam pulley without it being under any tension. So I have pushed this back, and exactly as I suspected, it reveals a little hole. I put my drill bit in there. Now we've got no tension. So what we need to do now is use this tool. Just cobbled something together that will fit into there and provide some kind of you know, not perfect fit, but it will provide some kind of resistance, so I can then use this 14mm socket on the cam pulley and undo that. So I have cracked tension off the cam pulley retaining bolt, so I can now pull this out of the way. The cam pulley itself will wriggle off and be pulled up and out of the way by said contraption. It just keeps it enough out of the way that we can do what we need to do. So that exposes the front end of the cam, which is exactly what we need. Next thing we need to do is to remove the distributor itself. So we can see there's a bolt head just there. That is a 10mm, and one just there, that is also a 10mm. Take those out and the distributor can be eased out towards the bulkhead. That's the bolts out of the way. So now it's just held in by the friction of two seals, and there we go. A little bit of twisting and pushing and that will completely come away. As you can see, there's been a bit of oil leakage on this one, so seal number 1 and seal number 2 will be getting changed. Now this shaft, you can only put the rotor arm on this shaft one way round, so the rotor arm will go back on the correct way, and this unit itself will only bolt up one way. However, there is some adjustment in the unit, and there is the possibility of having this 180 degrees out in the cam, which would obviously not work. It would cause your timing to be 180 degrees out. So yeah, I wouldn't worry too much about this moving a little bit, but when it goes back in, you want to put it in the right way, and if you don't, you'll be 180 degrees out on your timing, so you would then have to rearrange your setup to make it correct again. Next thing is to undo the cam caps, or cam carrier caps. So these seem to be 13mm or half inch. Half inch is a very snug fit on these, and what you want to do is undo each bolt half a turn at a time, because there's always going to be some tension on the cam from some of the valve springs. So what we do is we start from the outside ones. So that one there, half a turn, 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 and then half a turn on the middle ones last. Keep doing that until they're all completely loose, and then we need to take the cam caps, place them in the order that they came off, in the orientation that they came off, onto a piece of cardboard which we've marked out, so we know exactly where they go back, because they need to go back in the exact same place. So I've got all of the took all the nuts off, took all the caps off. We should now have a loose cam. So if we lift it up towards the back end slightly, we should be able to slide the front out of its position. I think it's just the cam seal itself that's catching there. Can we there we go, there we go. So we're out. That is the cam out. That exposes the buckets with the shims on top. Well, I got rained off, so it's the next day, and we've got old cam next to new cam. So what I'm doing here is just making sure, well, just having a look really to see what differences there are, or if, you know, if they look identical in terms of angles of where things fit in. So if we bring the cam pulley locating dowels up to roughly 12 o'clock position, we can see that the lobes are all in similar places, and obviously there's going to be difference on the duration and lift. And at the back we can see that the slots for the distributor are in the same place in relation to each other, so we're looking good there. We can fit this as if it was a standard cam, and everything in terms of the cam pulley and distributor should be in the same location, but there are adjustments available anyway for some fine tuning. So this is the T25 cam that's sold by ClassicSwede.org. Next job is to remove the buckets and shims. So if everything's in good condition, these should smoothly slide out. So there's the bucket So what I'm going to call valve number 1, closest to the water pump. There's the shim on top, and we should be able to just lift it out. Okay, so yeah, they do just lift out, but because the surface is so perfectly mated underneath, it sort of creates a suction with the oil film that's under there, so that does come out. So what we need to do now is place this bucket in a position on a piece of cardboard telling us exactly in relation to the engine where it's come from, so we can put it back in. We need to measure this shim and put it back with the bucket, but it's not necessarily going to stay with the bucket, we're just going to put it back for now. So I'm going to measure this with a pair of vernier calipers and write down the thickness of this on the cardboard next to this bucket, so we know which one is registering with that thickness measurement. So this first one is 4.05 mil. I'm going to write that down and pop it back where with the bucket that it came with, and put it in the cardboard and repeat with the rest. So here we have our piece of cardboard. Everything's laid out in its place. As you can see, all of the shims are between 4 mil and 4.05 mil thick. Now I was actually getting a measurement just under 4.05 and just over 4, but we're working to a tolerance of 0.05, so I'm just rounding it to the closest 0.05, considering any new ones we use will be an exact 0.05. So I believe, from what I can gather, the original size that was fitted was 4.025, so that might be what I'm measuring for the 4.05s. Hopefully that makes sense. But yeah, so now we're filling in our little equation chart here. D equals B minus C plus A. So we've got A and we've got C. So we need to know what B is to find out what D is. That means we need to know what the clearance is, and to do that we need to install some different valve springs, because that's what we're going to do. Once they're installed and we've got them in place, we can then reinsert the buckets with these shims in, fit the new cam as a trial fit, and nip it down, and we can measure the clearance underneath the cam with the lobes pointing up, and we can record the clearance here, and then we can figure out whether or not we need more shims and what sizes we need. Okay, so when we were last at the crank, we made sure that the crank was at top dead centre. What I'm going to do is I'm going to feed some rope down through the spark plug hole, if we can see that. I'm going to feed as much in as I can until I can't fit any more in. To do that, I'm going to need to wind the engine back a little bit, just to bring it down to give us some room and give us something to crush against. Then once the rope's in, I can turn the engine back towards TDC. That will push the rope up into the combustion chamber and against the valves, holding the valves still. That will allow us to use a tool to push down these valve springs and remove the collets to take the valve springs retainers out without the valve dropping down into the cylinder. You can buy tools which, well, there's various different designs that usually sit across these two mounting points for the cam caps, and you use some leverage to press down on the retainers. I don't have one, and I don't fancy spending the money on one, so I've made a really ugly tool that I can put over the studs, and use different length bolts and different bolt holes to get the correct position and height with the tool and from the end of a proper valve spring compressor that's used for off-head valve spring compressing. So I'm gonna move the cylinder back a bit. I'm gonna put some rope in the cylinder, move the cylinder forward a bit. I'm gonna press down on the retainer to compress the spring, and then once that's there, I'm going to use a screwdriver to press down on the valve just to make sure it won't move. Once I've confirmed it's being pinched in place, I will go ahead and remove the springs and install the new ones. So, not quite sure how much of that I'm going to be able to show you, but let's give it a go. Okay, so this may look a bit crazy, but I am set up, ready to. I've got my rope in the cylinder. If I press down on this now, that will depress the retainer whilst the valve stays in place. Now, I'm not going to do that just yet, because as you can see, this is in need of removal first. That's the old valve husher. There's a little bit there as well, so obviously these do go very brittle, disintegrate. Some of them, or parts of some of them, can be found on the insides of the buckets. As you can see, that one's been smashed to pieces and sort of disintegrated, so results may vary, but I'm going to remove those first to make sure there's no trace of those, and then I can take the collets out using a magnet on the end of a pickup tool. Then once I let go, the spring and retainer will come out. I thought I'd better try to record myself doing one of these. Just that gives you something to, it gives you a way of seeing what I'm talking about. You can see there how the collet's been dislodged now, and I'm going to try to pick that up. There we go. One collet on the end of the magnet. I'll take that off and hold on to that. Do not drop it. And then I'll pick the other one up by moving it around to the other side. Obviously I could be doing this a lot with a lot less issues if I wasn't trying to film it. What's the point in making a video if I'm not going to show everything that I'm doing, or as many things as possible? Obviously, if you have the correct tools, it's a lot easier. If you're doing this job on the bench where it's supposed to be done with the head off, it's 1,000 times easier. But we don't like to live like that. Can we get that now? Will you give us that now? Yes! There she is. So, with the second collet secured, I'm gonna let go, and that will allow us to remove the retainer and the valve spring. And the valve does not want to go anywhere, which is exactly how we want it. Now, at the bottom there, we can see, on the valve stem, we can see the valve stem seal. Now, usually, this is something that you should probably replace once you're down this area. Usually, if you just give them a quick wiggle, pull them up, they'll come out. Don't pinch them too hard and crush them, because then they'll be more difficult to take out. So that is valve stem seal removed, and that is ready for the new valve stem seal to be fitted, along with the upgraded valve spring kit. There we go. I've just cleaned down where the valve spring was, just to make sure there's no chunks of valve hush or anything lying around. Being careful not to scratch the bore that the bucket sits in, because it's a highly machined surface, so you'll cause some issues if you scratch that. Then we're going to install the new, I'll just show you the comparison here. So the new valve springs, the duplex ones, with the base plate and the retainer, versus the old ones. The old valve stem seal, I think that's one of the old hushers, and a new valve stem seal. You can just see the difference in the size in those seals, so that may or may not have been leaking. I didn't notice anything major in terms of smoke on startup, but you know, that's going to be a lot better of a seal there. I would say that old one's been in since new, 26 years, 132,000 miles. The base plate will not go over the valve stem seal, so it needs to go in first. I'm just going to use a little bit of engine oil for that. And same on the inside of the seal, because it's got a rubber interior that will fit over the slightly larger diameter seat. The valve stem itself, the valve guide even, and then just gently push it over, and then once it's past the grooves for the collets, it'll slide down a bit easier. Now this now needs tapping home, so I've got a 14mm socket there. You're probably going to get slightly better results with a double hexagonal style socket. And what you're going to do is you're going to listen for the tap, the sound to change. Once you know the sound has changed, once you hear that the sound has changed, you know it's all the way home and you don't need to tap it any further. So with the new seal in place, I'm going to put the duplex springs over the seal, making sure that they are in the seat correctly at the bottom and not perched on anything. You'll know this because the tops of each spring will be level with each other. Then we can put the retainer on top. So I'm now working blind because I'm prioritising the camera over my eyesight. It'll be so much easier doing the rest of these once I've shown you one. So these are conical, so you want the small end down. You probably couldn't even see any of that. We're getting there. We're sitting the right way up. And she's in. Now, I'm going to do the same thing with the other one. I don't want to lose it. Look how quick that one went in, that was crazy. Now I can lift, release my tool that doesn't quite fit in the engine bay, and there we have it. New valve springs, duplex upgrade with steel seats and retainers, using the factory collets without the valve going anywhere, without taking the head off. Rinse and repeat. Wish me luck. So that is all of the new springs fitted. I've just cleaned up the surfaces, the cam journals, replace the buckets in the same bores that they came from. Then I'm going to just lightly lube the surfaces with a bit of oil, or I might use a very thin sort of smear of assembly lube, and then we're going to place the new cam in place, and we are going to replace the cam caps exactly where they came from and tighten them down, starting with the, well, nip them all finger tight and then go around doing them half a turn at a time, because they will press down on some of the valves. So just want to distribute the force evenly whilst we're doing that, and don't force anything down more than it wants to be. And that would start with the middle two and work our way out for that. So I don't know if you noticed, but I moved the contraption that was holding up the cam pulley and just zip tied it to the back plate. However, all of that is pretty much no good, because when I turned the crank pulley round to allow the middle two cylinders to come down to put some rope in the cylinder, I noticed the crank timing mark. So someone, whoever last timed up this engine, has used 180 degrees top dead centre or bottom dead centre as a timing point. So because of that, I want to make sure it's right. I want to re-time it, so I don't really care about that anymore. I don't care about the belt slipping. So yeah, I've just, now that I've realised that, I'm gonna take the bottom pulley off, take the bottom timing case off, time everything up properly, and put the belt back on. So what I'm gonna do now is just ease the crank back a little bit. That just takes the pressure off this rope. This is the last cylinder that I did. Just did it. Cylinder 1, then cylinder 4, then cylinder 3, then cylinder 2. And that's all of our rope out. So what we need to do now is bring this back to TDC, just because that's where it was. That's where it was when we last had a cam in, so I know that we're back where we were in terms of piston location at least. So now I'll get the buckets in. Okay, so I've just lubed up, inserted the buckets, and I've lubed up the journals. Just did this last one, and I'm just going to put a little bit on the shims as well. So it's just a very thin film, just to avoid any scratching when we measure. At that point we're ready for the new cam to just sit in place. So I'm just going to make sure that there's a coating of oil on every lobe and every surface that's going to come into contact with a journal or you know, a shim. Okay, so I'm happy with that. So I'm just going to lower this gently into place. Feels really weird doing this. You know, without the seals, but that's fine. So I'm gonna roughly place it where as if it was also at TDC. Applied some assembly lube. I'm just gonna lie that over the cam, and then just gently send the nuts home. And now do that with the other 4. Okay, so that's the caps in place. I've reached the middle one, and the one after that I can't get the nuts on just yet. Well, not properly anyway, and the one at the end's even worse, but you can tell it's sat in the right place because you can feel it rocking back and forth on the curvature of the cam. So all that is obviously the lobes that are pointing down here against the shims are lifting the cam up. So we're going to start by nipping these ones down a little bit. That should bring the cam down, and that should allow us to start on the next cap and the one after. So I've managed to get the next bolts on, and as I give them about half a turn at a time, it brings the cam down little by little. And then we can see just poking up through the last one now, so I'll give them all another half turn so we can just get started on this last one. basically just going around and feeling where there's slack, taking up the slack. So that's all of them nipped down until I can feel some resistance. So I'm now going to tighten these up, starting with the middle two. These are tightened to 20 Newton meters, so I'm gonna get them fully torqued. And then these two, and then these two, and then these two, and then these two, and then we are fully torqued down. Okay, so that's all the cam caps torqued down to 20 Newton meters. Now I'm going to move the crank about a quarter of a turn just to try and have all of the pistons halfway down the bore. It's just so that when we're moving the cam, it's just belts and braces. I know it's a non-interference engine, but with an aftermarket cam, if you've got more valve travel, you don't want to be taking the risk. I don't actually know how much clearance there is on these engines with standard cams, so I don't want to be taking any chances. So that's the pistons well away from the cylinder head. It's a 14mm socket just to turn the cam. What we want is just for this situation to be happening here, where we can see that none of the lobes are facing down. So if I just get some turniture going, we just want to see that both lobes are facing about as up as they can face. And at that point we can measure the clearance between the valve bucket shim and the cam. So here's our feeler gauge, and we've got our magical mathematical cardboard calculator there telling us that the spec is 0.35 plus or minus 0.05 millimeters. So what I'm going to be looking for is 0.35. So here we have a 0.3, and that's also very easily moving underneath, no resistance. Here's a 0.4. Now I can't get that under, that's pinching. I can't get 0.4 in. So that's good, because that means we're somewhere between 0.4 and 0.3. So this is 0.35, and what I'm feeling there is it's actually going through okay. I can't feel any resistance there. So we have somewhere between 0.35 and 0.4, which is within 0.05 of a mil tolerance, which means that particular valve bucket does not need any different type or size of shim thickness. So that one, it will go in and I can feel a slight pinch. That tells me that it's bang on at 0.35. We can test that by checking 0.3, well, it just goes in a lot easier, and 0.4 that's not going to go in. So again, those two are bob on. We don't need to buy any shims for these. You can get shim kits which just give you a selection of shims, but I don't see the point in buying a whole kit of shims when you might not need any, or if you do, you might only need one or two. Anyway, I'm going to repeat the process with the other lobes and write down my results and see which shims I need, if any. So I've finished doing my measurements. As we can see, I've got my clearances written down there. So for example, this one, 4.05 shim thickness, clearance is 0.40, the spec is 0.35. So what you do is you get the clearance of 0.40, you take away the spec of 0.35, leaving you 0.05. You then add 0.05 to your shim thickness, which gives us 4.10 shim thickness. Now I've already got a shim thickness of 4.05, so the difference between what I've already got and what I should have is 0.05, and we're allowed plus or minus 0.05. And this one, started off with 4.4 clearance minus the 0.35, so 0.05 again. Then you get the 4, you add a 0.05, so 4.05, and again we're only 0.05 away. 0.05 away on that one, 0.05 away on that one. That one's bang on, that one's bang on, that one's bang on, and that one's bang on. So everything's within spec. So there's no point in ordering any parts, which means we can just crack on with the reassembly. So that's the camshaft back out. It's got like a conical top and a flat bottom, so you just put the flat piece over the valve stem, and that is your husher installed. That's all the hushers installed and all the buckets back in, and as you can see, I've just give everything a nice thick smearing of engine assembly lube. Just a very thin smearing on the end race there that's used for the cam seal to sit into. Just want that to seat nicely. And on this rear one, just on the sides, which is used as a thrust bearing point by the looks of it. So I'm going to do the same to the cam now. I'm just going to lube up all the journals and all the lobes, and then reinstall the cam as we did before, whilst remembering to apply a nice thick layer of engine assembly lube to the caps, as we did, well, not as we did last time, but more so than I did last time. Tighten that back down to 20 Newton meters. That will be the new cam installed with the new springs, the hushers, everything within spec, ready for the engine to be timed up and the new cam pulley to be installed. So one thing different about the last time is that I've just slid a new cam seal onto the end of the front of the cam there, and applied some more engine assembly lube quite liberally. That can now go back in. So another small difference is on these end caps, they seal against, they go that way around, and there's part of them that creates a seal. This bit here creates a seal between the head and outside of the engine. There's no gasket there, you don't have to do this, but I like to put a little bit of sealant, so I'm just using Rhinzo seal. It's pretty decent instant gasket and sealant. Obviously trying to use only one hand, you just want a really thin smidgen, because you don't want to be applying enough to make a difference to the clearance. I'm just going to spread this, so I'm going to do the same thing with the back one. So that's everything torqued back up. Now, what I have noticed, just looking at the old cam pulley, if you look at the cutout there for the locating dowel, that lines directly up with the timing mark, which is in a trough from where the belt sits, one of the teeth of the belt. If you look at the new adjustable cam pulley that I bought, we've got the same, it's the same diameter, you can line them up together and they're exactly the same. So, you know, it's the right size, it's got the right amount of teeth, the right size of teeth. However, this central part, which has got the groove in for the locating dowel, and it's got 0 marked on there with a line corresponding on the other piece that moves, they relate to a peak, not a trough. So yeah, that means that the timing on this is going to be half a tooth out from factory. Which is a good job, it's adjustable, but yeah, slightly annoying. However, I will fit this. I'll fit this, and you know, all I'll have to do is I'll get this, the 0 mark on this, to line up with the timing mark on the back plate, which will be there, and I'll get the crank and the intermediate shaft timed up, and obviously the tensions from one side of the belt, the other side is all lined up. So what I'll do is I'll get the belt taut from the crank to the intermediate shaft and the intermediate shaft to the cam, and I'll decide which way I'll move it by half a tooth for it to sit in the belt properly. So it'll be half a tooth away from the top dead center position, and then obviously I can make adjustments to it using the adjustment on the cam, which, looking at it, I would say you're probably going to get up to 2 teeth of adjustment there, which is quite a lot, so shouldn't be any issues. So I can put this on next. I've been in touch with the person that I bought it from, and they said they're about 5 degrees out and that I should make a new line, a new 0 line. So, a bit strange, not ideal, but it's a workaround. I'm glad they said that, because I was a bit confused as to what the situation should have been there. However, there's also another issue which I should have spotted, really, because there's a review on the website for this that mentions that this cutaway here isn't big enough to accept the dowel on the end of the cam. So I had to file away at the one on the new pulley to make it deeper, and I think a little bit wider. So that had to be done to get the new pulley on. So this is the old cam, got the same dowel on it, so it would fit over this centerpiece fine, but it wasn't, the groove wasn't deep enough to accept that whole dowel. So that 0 matches this little score mark on the trough of those teeth. So as you can see, it's almost in time. It's actually set perfectly for where the oh no, it's not, it's set 1 tooth out from where it used to be, where you would have been showing as correct. I've just put the nut back in, and now I'm going to use a homemade tool that I made to just these just go into the holes in the pulley, and I can use this bar now to hold the pulley steady whilst I tighten this nut up to 50 Newton meters. I think it's 51 Newton meters it wants to be tightened up to, but my torque wrench goes up to 50. It did actually register just over 51, so it is torque to spec. Next is this distributor shaft. So I've got a little green seal there and a big green seal there. I'm going to use a pick to remove those, and I'm going to tidy the whole thing up, just clean the whole thing up with a bit of brake cleaner and a rag, and then lubricate and install some new seals, and then that should slide into the back of the cam and fit snugly, where I can re-secure it with its 10mm bolts. So that's looking somewhat better after a good spray and wipe down. Just going to apply a little bit of engine assembly lube to the seal seats. So you can see I've put a little bit around there and some in there, and I've put some in there as well, just on the grooves that go into the back of the cam. Just help keep the whole thing a little bit on there, just for the rotor arm. So I'll fit some new seals to this now. Okay, there we are. So new seals in place, a little bit of engine assembly lube on the outside of the seals so that they slide into place nice and easily, and this can now be slid back in. I'm just going to refer back to, because I did spin it around a little bit whilst I was cleaning it, I'm just going to refer back to the earlier footage as to which way round that needs to be. So looking back at the footage, it's quite obvious now, but you can just see that little square there and that little square there. You need the two prongs that sit inside the end of the cam to be in line with those, and on the back you want the sloped and cut out side of the shaft to be poking up in between the two mounting points, or should I say down in between the two mounting points, or you could say opposite this feature here. We're looking a bit different now, aren't we? So here's what happened. I noticed that there was a timing mark on the crank pulley that was a factory timing notch that was opposite, almost 180 degrees opposite the one that was marked. I thought, something not right there. I'm going to pull this off and see what's happened, because I don't understand how that's possible. So I will show you what I found. So this is what I was greeted with. There's the timing mark that was labelled as top dead centre, and it was in line with top dead centre. There's obviously nothing there. Almost exactly opposite is the factory timing grooves, which, you know, once you're looking down at the engine and you've got a timing light on it, you can use to line up to the timing marks on the timing cover. So how the hell was that at top dead centre? Well, I found that out when I looked at the back. Just ignore that line that I've drawn, but you can see an indent there. I was like, what the hell is that? When I pulled the belt drive off, well, that doesn't look right, does it? I think what's happened here is it's snapped off, and someone's tried to weld it to repair it. This is the bit that slides into the groove on the crank, so this was fixed to the crank correctly, but obviously as long as you were timed up and you knew that that's where it was, the engine would run fine. However, that should be a raised bump which would sit inside the groove on the back of here. I know these are known for going, but I thought it was this bit that snapped off, not that bit. Maybe it's both. Either way, they've tried to repair it by the looks of it. They've put a too wide piece of metal there, and it wouldn't fit into the groove if you wanted it to. And what they seem to have done is just timed the engine up, got it to top dead centre, put the belt on, made sure it runs, and then just found top dead centre again and put a mark on the pulley for the next person. I don't know. Anyway, so this is now turned into harmonic balancer replacement, crank belt drive replacement. Might as well do timing belt, might as well do, you know, the tensioner. So I thought I'd place an order from classicswede.org, which is where I buy almost everything from for this up to now. So these were shown as in stock. I ordered one. I ordered the steel upgrade to this, which is a slightly different design, and it requires you to either have the upgraded pulley that someone designed for it to work with, which I can't find, or you're supposed to have to grind a groove opposite the one that comes from factory to fit the keyway. Anyway, these steel upgrade ones are you know, supposed to be more reliable and takes away that weak point in the engine. So got everything ordered. Then I was told that the harmonic balancer was mistakenly advertised as being in stock. It's not in stock. It's not in stock anywhere in the UK. The guy tried to order some from Sweden and they don't have any in stock either, so he doesn't know when they're going to get any in stock. So I've had to say, right, send me everything else. So he sent me everything but that, and I'm going to have to reuse this. It's not failed, but it just looks a bit old and tired. Wouldn't be surprised if it's the one that's been on since new, 27 years ago. It's all very, you know, the rubber's rock hard and cracked in some places. So that's why there's a mark there. That's where I'm gonna cut a groove to accept this new belt drive. The parts have arrived. Let's see what we have. What is this? Belt tensioner. Okay. Made by Gates, so decent quality. Or is it? Seal's broken. Well. Seems to be. I don't know if that's just a dry storage mark, but yeah, it feels nice and stiff. So that's the genuine Volvo timing belt. In order to not disappoint me and delay me any further, he's actually taken one that was in use because of the mix-up. So it's not you know, in the package, or it's not never been fitted to an engine, but it is the part that I ordered. So this is the little key that goes into the little slot there. It's quite a nice, satisfying fit. So that would slide onto the crank, and this key would go into the keyway in the crank. That would obviously provide drive. Then, once that bottoms out on the edge of there, this sticking out the top would go into the groove that I am about to cut into the back of the harmonic balancer to drive that along with the crank pulley. And I believe it needs to be a little bit wider as well, so 5.7mm. So I'm going to get that ground in, and this is obviously now going to turn into a bigger job, but at least it'll have all new timing gear and timing belt along with tensioner. The harmonic balancer obviously won't be new, but it'll get the engine back up and running, and when that does come into stock, he's going to send that out to me. I'm just going to have to put a groove in the back of that as well to fit, and I can just fit that by itself. Okay, I've made a slot in the harmonic balancer, which will now happily slide onto the crank with the new steel belt drive. And I've also just widened the slot in the washer, the belt guide washer, to allow the woodruff key to sit through that as well. Tensioner's off, so I'm going to go and fit the new tensioner to the spring, because you only get this bit in the new tensioner. So all you need to do is compress that pin in a little bit further to be able to pull this drill bit out, or pin if you've got the correct pin, and then you just take that bar and the spring, insert it into the new one enough to get the pin back in, and you can slide that whole assembly back on into place. That'll be ready to release the tension onto the belt once we've got the belt fitted. So it was a bit fiddly, but I did manage to sort of use the palm of my hand, just pressing down, using my body weight, holding this still, use the palm of my hand. Might want to cover the end of that with a rag or something, because it does dig in a little bit, but it's not, you know, you don't need a vise, but if you had a vise, that'd be the easy way of doing it. So I'm just going to get the new one now. There we are, that is the pin and spring attached to the new tensioner. So we're going to send the tensioner over the stud, locate the end of the pin onto its stud, and then this locating point will go into the head. At that point, I assume this timing cover is meant to, yeah, just clears the top, so that's ready to go there. We can slide the washer on and tighten the nut. Oh, don't tighten it, just leave it finger tight. So we're in our primed position, ready to fit the belt. Just need to make sure we're at top dead center on the, we're at top dead center on the crank, and then we need the cam. As you can see, the mark on the front of the cam pulley there is in line with the dimple. That I'm just going to use my phone down here to tell me when that's lined up. So I'm going to say that is perfect. Then we need to get the crank timed up. I'm going to pop on the back washer, insert the woodruff key into the keyway in the crank, insert the crank belt drive, so I'm just going to hand tighten this into place. Okay, with that on, I'm just going to fit the harmonic balancer. Okay, so I've slid the harmonic balancer on, insert the bolt for this, and just tighten this up, and then get a socket on this and use it to turn the engine over. And we're going to be turning it until we see the timing marks on the pulley line up with the 0. Providing the modifications have been done correctly, that should bring us to top dead center. Now, because there's a possibility that, you know, things can go wrong, we want to make doubly sure. What I'm going to do is I'm going to insert very long screwdriver into the spark plug hole, into the combustion chamber, which will sit on top of the piston on cylinder number 1. As we turn the engine, we'll be able to feel that coming up and see that coming up, and as we hit top dead centre it will stop and it'll start to go back down. That's when we know we've gone too far. So what we need to do, you could be as accurate as you want with this, because you can swap the screwdriver out for something, you know, more stable, like a steel bar, and then you can attach a DTI gauge to that and measure the minute movements towards the top of the stroke. But for the purposes of making sure it's on the correct tooth of the timing belt and not the next one or the one before, you know, just some careful feeling of whether or not something's travelling up or down in the bore should be suffice. That's now at top dead centre. I've pulled the harmonic balancer and the timing cover back off, so now we've got all 3 pulleys in the correct position. We can fit the belt. If you do get a Volvo branded belt, I don't know if the other brands will be the same or not, I doubt it, but they come with these handy lines, so that should line up with the marking on the cam, and then there's one further down to line up with the marking on the intermediate shaft, and then there's a double line there which should line up with the groove or slot in the crank, or in this case woodruff key. So I'm gonna fit the belt now, starting on the cam, going down to the intermediate shaft, and then around the crank, and should fit nicely just behind the tensioner, which is currently not under any tension. So there we have the belt fitted, slides on nice and snug. So we have this line on the belt, lines up with the timing mark on the pulley and the timing mark on the timing cover. Back plate down here, we have the mark on the belt lining up with the mark on the pulley and the mark on the back plate. And down here we have the 2 marks on the belt, which, if you count the teeth per groove, the one that's only half in is going to go in there. The next empty one will go in that, will have that tooth in it. The next empty one will have that tooth in it, and the one with the 2 lines on the back will sit nicely in the one above the woodruff key. So we're all good. Now what I'm going to do, make sure this is just finger tight, I'm going to apply a lever force onto here to take off some of the tension. Then I'm going to pull this pin out and then release the lever. That'll tension the belt. Okay, so with the tension on, I'm now going to tighten this nut to 51 Newton meters. There we go. That's all tight. So now the engine should be in time. Put the little belt guide washer on for the opposite side of the belt. Then we can reinstall the harmonic balancer. Then we're going to turn the engine over twice, so 720 degrees. There we are. So we've not got the the lines on the belt anymore. That's because you know, they will drift as the belt goes round and doesn't have an even amount of teeth between each pulley every time. But if we did turn it around enough, it would eventually line back up. So we've got timing mark there lining up with that timing mark. this one lining up there, and it's harder to see, but the crank, you can just see the timing marks facing pretty much bang on up. That would obviously correspond to a timing mark on the timing cover, which we can now fit and you know, verify. But just for fun, I'm going to keep turning it over until these belt marks line back up again. That's now in with the mark, and if we look here, that one is sitting in with the mark as well. So if we bring this up to in line with the mark, check that. Yeah, we're bang on. And then if we whip the pulley off, put the timing cover on and put the pulley back on, that should line up with the timing mark on the belt cover. So that's the bottom timing cover in there. One bolt is 10mm, the other bolt is 12mm. Can't find any torque specs for these, so I'm just going to tighten them to 12 Newton meters, which seems like a half decent you know, torque setting for an M6 an M8 thread bolt. With that fully fitted, we can now refit the harmonic balancer for the last time. Okay, so as we can see, harmonic balancer's on. We've got the factory grooves that are lining up with 0 on the timing cover. That lines up with its notch. We can't show you the intermediate shaft, but we know it's all correct because we've checked it without the cover on. Obviously, if you're not modifying things, you're not changing cam pulleys, and you're not making slots in things, and you don't have to do half of this. Yeah, so now this is a 24mm bolt on this bottom pulley, and that needs to be torqued up to 60 Newton meters plus another 60 degrees. So my little digital torque wrench can only go up to 50. Well, it's only rated to 50, it'll measure to about 52, 53. So I'm using the bigger one for this bottom pulley. So that's our 60 Newton meters. The flats of the bolt head, each one of those represents 60 degrees because there's 6 of them, and 6 times 6 is 360 for the circle all the way around the bolt. So if you mark, say, that flat piece there that's facing up, turn the bolt until the next piece behind it is facing up, you know you've turned it 60 degrees more. So that's what I'm going to do. So now that that's back on, everything else is in situ. I can just replace this top timing cover, pop the valve cover back on, give the engine a quick spin over for 15 to 30 seconds just to build a bit of oil pressure. I have got these unplugged just so I don't go squirting fuel into the bores. You can pull the fuse for the fuel pump if you like, but it was more convenient for me to just pull the injectors or the injector plugs. So yeah, pop the top timing cover back on, fire it over for 30 seconds, plug the injectors back in, reinstall the spark plugs, put the dizzy cap back on, auxiliary belts, put the pipework back together that I had to undo to get better access to stuff, and she should be ready to fire up. So for the valve cover, these are 10mm nuts. I'm going to be tightening them to 20 Newton meters. I've put them all on hand tight up to now. I'm just going to gently snug them down, starting with the middle two, and then working in a crisscross pattern to the outside. And then I'll do the same thing with the torque wrench up to 20 Newton meters. Right, that's everything back together, so let's see if she'll fire up. Oh, that's a good good sign. Wow, okay. We're running on 3, but sounds like we're on 4 now. Well, that is a very good result. Well, you saw me running in the cam there. There's not a specific braking procedure as such for this cam, that I've been told anyway. Basics of running in cams usually is a case of keeping it above idle, 2,000 to 3,000 RPM for the first 20 to 30 minutes. So that's what I did. For some reason the aircon, the AC compressor was kicking in momentarily, even with the aircon button off. So I don't know if I've got a dodgy aircon switch or whatever, but I managed to solve that by just turning the fan completely off, and that disables the air conditioning compressor anyway. That just kept the revs at a more stable speed, even though you could argue that a variable speed of up and down a little bit is probably even better for the cam to be warning at. Either way, after that, checked all my fluids, made sure everything's fine, yeah, it's time to take it for a spin now. And then once we've done that, it'll be a case of change the oil, sticking the oil filter on, fresh oil in the engine, and any of the any material or anything removed or that comes loose during the installation or the braking period, any excess lubricants or assembly, grease or lube, you know, has a chance to come out then in the oil drain. And yeah, can see what life is like with a T25 cam on board. Well, I don't know about you, but to me, I can definitely feel the difference. The difference is quite noticeable when you get up to, I would say, it coming on to boost, and the torque curve seems to be more gentle on the lower revs, which is what this cam should be doing. It's not as if it's being more gentle, it's just that it's not going to bring in the main torque until it'll have a, you know, the torque and power curve will be slightly further up the rev range now, so that is the case. When it does come in, it's nice and strong, it's nice and linear and powerful. It does stay very happy, and it feels so smooth and so happy to rev all the way up to 6,000 RPM, which I'm pretty sure is around about that this is currently limited to on the standard ECU, which obviously we can do something about that. And this cam should provide a noticeable increase in performance and power right up to about 7,000 RPM, so it's advertised. So yeah, that is this installed. If I do need to make any adjustments, I can adjust the pulley. The pulley's adjustable, and I may do that anyway, just to mess around with where in the power band I am and figure it out and see what I like best. However, there's probably no point in doing that right now, because the next thing is going to be bigger turbo, bigger injectors, bigger intercooler, and chipped ECU, as well as a bigger MAF. So there's no point in trying to set something up now on the way that the engine is now to make it run perfect for what there is in place now, with the air going through it and the hardware that's installed, to then change everything and suddenly it needs tweaking again. Or does it? I wouldn't know. I'd still need to tweak it again afterwards to find out whether I've got it set optimally. And the chances of having it set optimally from installation, well, I don't know. Seems to me very unlikely, but there you go. So yeah, I'll have to get ready for some more upgrades next. Then the weak point then is going to be the clutch, which is probably not going to be able to handle that power. The flywheel itself probably won't, so we're going to have to do something about that as well. So I think it's time to order some more parts and see what we can come up with for the next adventure.